All right, these are going to be some more quadratic word problems. These ones, however, are going to all be not such pretty numbers. So we're going to use our calculators to really help us here. So if we look at problem number 1, it's talking about a boat in distress, and it launches a flare straight up with a velocity of 190 feet per second. The height of the flare in feet is modeled by the equation that it's given to you, and it's asking you what is the maximum height of the flare. So if we look at this equation right here, what we can see is that it is a quadratic equation because it has, in this case, a t squared in it. And if we wrote it in kind of more standard form, it would look like this. We typically list our squared term first. So it would look like this, okay? What I know is that this is a parabola then that opens down because my number in front of my t squared is negative. So if I think about the graph of this, I know that it's got to look something like this. Part A is asking me what its maximum height is. The maximum height is what the vertex is. So I could do one of two things. I could find it by doing negative b over 2a. It is not going to be a pretty number though. And then plugging that back in and getting the y coordinate of it. I could do that. Or you could use your calculator to help you, which we're going to practice here. Okay, so when we use our calculator, we first of all want to put this function into our y equals key. So if you're on your main screen, go ahead and go up to y equals, and we will put this equation in. So we have 190, we're going to use x instead of t, minus 16x squared. So this is what this looks like. And now the tricky part to this is to get our windows set. We're going to have this parabola that is not going to show up very well on our screen, just so you know. So it's going to look something like this. And we are not seeing nearly enough of that parabola. I know that I need to see higher, and I know that I probably need to see wider. I don't really care truly about negative time, so I am going to set my window right here like this. I'm going to set my x min at -5 because I don't really care about anything to the left of the y-axis so much. I don't care about negative time. I will set my x max at 20, let's say. And if I'm going from -5 up to 20, let's go up by 2's. Okay, the x scale just tells you what to go up by. Then, similarly, I don't really care about anything below the x-axis either, but I'll set it so that I can see a little bit of it. I am going to go from -100 all the way up to 600, and I'll show you why. And this is just a guess, you guys, and I'll play with this next one a little bit. But if I'm going from -100 to 600, I am going to go up by 50s. And now if you go ahead and hit graph, you should be able to see everything that you need to see on your parabola, which you can. Okay, so part A is asking you what the max height is. The max height will be up here. And you can get that on your calculator by doing second trace. And then in this case would be maximum, number 4. And you're going to go a little bit, put your cursor, scroll your cursor a little bit left of that blue dot, hit enter, a little bit right of that blue dot, hit enter, and right on that blue dot and hit enter. And you can see that your maximum height is right here. So actually, and this is what time it occurs at 5.94 seconds. So I actually want you to write this for part A, okay? Where am I going to put this? I want you to write this sentence right here. The max height is about 564.06 feet when x is about 5.94 seconds. Okay, so I want to know not only what the maximum height is, but when it occurs. Okay, and actually, I just answered the next sentence now. How many seconds after the flare was shot was it at its maximum height? I just answered that it's at about 5.94 seconds. And then the last thing, when is the height of the flare? Part C asks, ignoring the height of the boat, how many seconds will it take for the flare to hit the water? Okay, so we're ignoring the height of the boat. How many seconds will it take for the flare to hit the water? If you go back to your graph, this is the point right here where it will hit the water. So to get that point on your calculator, you will do second trace, and this time you will go to 0, which is number 2, and you will scroll your cursor till it's just a little bit left of that red dot and hit enter, and then a little bit right of that red dot and hit enter, and then right on that red dot and hit enter. And you can see that it hits the ground after at about 11.875 seconds. All right. This next one now, we're going to do a similar problem here. This is talking about NASA that launches an aircraft in a parabolic arc to simulate the weightlessness experienced by astronauts in space. The height of the aircraft in feet, t seconds after it begins its parabolic flight, can be modeled by the fancy-dancy equation that you see there. Okay, so we're going to go ahead again and do this and talk about how to set our window on our calculator. All right, so we're going to go back to our calculator. We're going to put this equation in, and then I'm going to show you how to sort of play with your window on this one. The last time I just said it for you, but we're going to play with it this time. Okay, so when we put that equation in, we have negative 9.09. Again, we'll use x instead of t. You know what, I'm going to clear this out. Negative 9.09 x squared plus 590.85x plus 24,398.6875. All right, so if I graph that, and notice I just have my window set how it was before, so it's probably not going to be real great. In fact, I'm not even seeing anything here. Okay, the reason I'm not seeing anything is because my parabola is outside of the window. My calculator is kind of flicking here. So that means I need to be able to see a bigger range of things, okay? So we are going to set our window a little bit wider right here. So right now my window goes from -5 up to 20. I am going to set it a little bit wider and go from -50 up to 100, okay? And if I do that, let's say that I will go up by 10s. Now I'm just going to stop right there and see if I can see anything now on my window. So now I can see the left side of the parabola, and hopefully I should be able to see the right side of the parabola. But what I can't see is I can't see high enough, okay? So if I want to see higher on my parabola, what I need to do is change my window, and I need to change my Y max. And so I am going to put my Y max right now higher than 600. I'm going to put it at 5,000. Okay, let's see if that helps. If I'm going from -100 to 5,000 though, let's go up by 1,000. Okay, and go ahead and hit graph and see if this helps. Okay, I can see that it's better, but that I still need to see much, much higher than I am at. So I'll go back to my window and I'm going to change my Y max again. This time I'm going to go much bigger. Let's go, let's see, that didn't even get me close. So let's go to, I have no idea, 40,000. Okay, and let's go up by 2,000 this time. And let's see what happens here. Okay, now I can see everything that I need to see. Okay, so the question, the next part of the question is, what is the maximum height? So again, the maximum height occurs right up here at its vertex. So in order to get that point, I would do second trace, and I would do maximum, and I would go a little bit left of that red dot, hit enter, a little bit right of that red dot, hit enter, and right on that red dot, and hit enter. Okay, so I can see that the maximum height is 34,000 at 32.5 seconds. So part A, I would want you to write this. The max height is 34,000, and make sure you put units in here, and my units are in feet, at 32.5 seconds after it begins its flight, basically, okay? So there is that. Part B says if it is only safe for astronauts to have a 45-second free fall, how high will the aircraft be when they have to turn the engines back on again? It says the astronauts will feel weightless for 45 seconds after the aircraft reaches its maximum height. So it's going to reach its height at its maximum height at 32.5 seconds, and then after it reaches its maximum height, they can free fall for 45 seconds. So if you think about this graph, this is what's happening. Okay, so it took them 32.5 seconds to get from here to here, and then they can continue to fall at weightlessness for 45 seconds is basically what's going to happen. And so you need to figure out this. First of all, 32.5 plus the 45 seconds means that it's at 75.5 seconds that it will have to turn its engine back on again, okay? And then to figure out what its height will be at that point is you can go back up to your equation, which is this guy right here, and you can plug in 77.5 and figure out what you have. Okay, and I will tell you that it'll be about 15,592.75 feet above the ground. Okay. You could also go to your calculator if you want. I'm not going to show you that right now, and go to a table and look at that, but we're not going to look at that right now. All right, last one, and we're just going to really practice setting our window here. The height of a punted ball can be modeled by the equation where the height of the ball is given in meters and the time is in seconds. So I've got that right there, the equation right there. We're going to go ahead and stick this into our calculators right now and set our window appropriately. And the hardest part to this is setting your window. Answering the questions isn't so terribly bad. All right, so in this case, our equation is negative 4.9 x squared plus 20x plus 1. Okay, now I know my window is going to be way off from the last problem. Okay, so you can barely see my parabola down there. I don't need my window nearly as wide and nearly as tall. So I will go back to my window here, and let's try just going from negative 5 to 10 in this case, and we'll go up by ones. I'm just guessing, I really don't know. And my y-mins, let's go from negative 100 to positive 100, and let's just see what happens. And we'll go by tens there also. Okay, let's see if this is a decent window. I really don't know. We're going to just play a little bit. Okay, so I can see the peak of my parabola, which is good. So it asks me what the maximum height is, and again, you're going to find the maximum height by doing second trace, a little left, a little right, and hit enter. I will tell you that the maximum height is 21.4 meters. I'm just going to not do that on my calculator right now because I think we've taken enough time here. So the maximum height is 21.41 meters, and you can figure out what time that is. Obviously, the x coordinate would be there, but I know that that's the max height. Then the next question says, at what time in its flight is the football within 5 meters of the ground, okay? So basically what that means is this. The function that you were given here goes like this, okay? And if it's within 5 meters of the ground, that means that this function right here has to be less than or equal to 5. So I'm doing part B right now. I just want to have this function with me. That function, negative 4.9 x squared plus 20x plus 1, better be less than or equal to 5 if it's within 5 meters of the ground. And so then I will subtract 5. Okay, and I will have negative 4.9 x squared plus 20x minus 4 is less than or equal to 0. So now what I want to do is I want to actually graph this function now and figure out where it would be 0. Okay, so I'm going to go back to my calculator. I'm going to go back to my y equals. I'm going to change my function a little bit. I'm going to change that last thing. Instead of being plus 1, oops, it should have been plus 1, not plus 11. Instead of being plus 1, it's going to be minus 4 right there. Okay, and so there's my function now, and my window hopefully will be okay, but this is what my window will look like. And I want to know when it's within 5 feet of the ground. Now, that's going to happen when it goes up, and it's going to happen again when it goes down. So there's actually going to be two answers to that. One of them will be right here, and one of them will be right here, okay, because that's when it's 0. I will do one of them for you, and then you'll repeat the process to do the other one. So we'll do second trace and number 2 to figure out this. And I'm going to do the left-hand dot here. So I want to put my cursor a little bit left of that red dot, hit enter, a little bit right of that red dot, hit enter, and right on that red dot and hit enter. And I will tell you that the first time it happens on the way up, it happens at 0.21 seconds into its flight. And then you would repeat that process again, second trace 0 to get that one. And that one would happen at 3.87 seconds above the ground. So you've got two answers, 0.21 seconds and 3.87 seconds that answer part B of that question. Okay, all on your calculator.